Now here are some cool things about vertex form, because vertex form is like really useful, and we'll come back and talk about this when we talk about transformations. But these are some of the easiest and coolest things that we can talk about right now. So we have our equation up there. The first thing is that we can find our vertex. So basically what this form tells us is where we're moving our vertex to. And our vertex is going to be h comma k. Now we can also define, like we can tell what kind of concavity it is or what shape it's going to be based on our number a. And this is going to be a thing that you can see in your standard form. So if you go back to your standard form assignment and look at everything that has the a, you'll be able to see this pattern. So if a is positive, then the graph is going to be concave up. Remember, concave up looks like it's opening upwards. If a is negative, then we're going to be concave down. So a positive, concave up, it opens up. A negative, concave down, opening down. Here's another cool thing that goes along with that. And it's the fact that the minimum and the maximum is going to depend on, the value of that is going to depend on our k, and it's going to depend on our a as well. So what a minimum and maximum is just where our lowest and our highest point is. So if a is greater than 0, we have something that opens up as a concave up. Our lowest point is going to be at our vertex, because that's just like our starting point. We can't go any lower than that. And that's going to be at h comma k. So our k is going to be involved with our range, which is our y values that we can get out. And what's really interesting with this, so if a is greater than 1, we're going to be opening upwards. So if a is positive, we open upwards, we have a concave up. K is going to be a minimum, because our vertex is at the lowest point of the graph. We're not going to have a maximum, because we can never get to infinity. Like, it's just never going to happen. We go infinity, infinity plus 1, infinity plus 2, infinity plus 3. It's not going to work. But we can come down here, and our vertex is going to be our absolute lowest point. It's going to be our minimum value. Same thing applies if a is positive or if a is negative. So if a is negative, we have a concave down equation or function, and our vertex is still going to be at h comma k, but you'll notice that it's going down. So we have a top. This is the maximum value we can ever get to. And negative infinity, we can get really close, but we're never going to get there. So we're not going to have a minimum. And we can use all of this to help us graph it. So we're given an equation. What we're going to want to do is we're going to want to find the vertex with the h comma k. We're going to want to build a table around the vertex, because remember, our vertex is on the axis of symmetry. That means that we can cheat. We can copy and paste it. If we find it on one point, on one side, then we know that on the other side, that's the same exact distance away from the vertex. It'll be the same exact number for y. And we can use these things like the concavity and the min and the max to graph it and to make sure that we're actually doing it right. So let's look at this equation here. First off, our value of a is negative. You'll notice this right here. It's a negative number. Since it's negative, we expect it to open downwards. It's going to be concave down. So if our graph starts coming out looking like this, if our graph comes out up, we know that something is wrong and we need to stop and make sure that we're doing it right. Now we need to find our vertex. Well, a vertex is at h comma k. Here we have our h. Remember, we want to take the opposite of it. So the value of h is 2. And here we have our k, and the value of k is negative 2. It's outside of those parentheses, so we don't care. It can stay the way it is. That means that this is our x value that we're plugging in. When we plug in 2, we get out negative 2. So if we're to draw our axis of symmetry right here, because remember, our vertex lies on our axis of symmetry, if we plug in 2, we get out negative 2. That's our vertex. Now we're going to start plugging in some easy points. An easy point to plug in would be 1, and after using some stuff on my calculator, I get out a negative 4. And if we're to plug in a 0 here, we get out a negative 10 on my calculator. Remember, we can mirror it across, so that 1, negative 4, that's 1 away from the vertex. 1 away from the vertex to the right is at 3, so we'll still be at negative 4. 2 away from the vertex is at 4, We'll be down here at negative 10. Something to note. Remember that we were doing this with modeling them. We had, oh, let me draw this really quick. There's our pretty graph. And guess what? It does open concave down. But something to note, when we were modeling these things, we would take the first difference, which in this case would be -2, and in this case, it would be -6. And then our second difference, and we'd notice that our second difference would be double that value of a. So the difference between -6 and -4 is -6 and -2 is -4. -4 is the same thing as 2 times -2, which that makes sense. You notice that here, pay attention to these numbers. If you do this graph for every single thing, you will find a pattern between a and these numbers here. That's going to be my cheat in helping you to figure that like exploit. Now we're going to do another one. It looks a little bit more complicated because we have a fractional value of a, but that's not anything to be scared of. Because first off, we're going to find our vertex. And where is our vertex at? Well, actually, let's check this. It's a negative a, so we're going to go opening downward still. What is our vertex? Well, our vertex is at h comma k, which means that what is h? H is the opposite of +3, so it's going to be at -3. K is the same thing as it is here, so it's -6. So our vertex is going to be at -3, -6. We're going to be way down there. So remember, when we plug in -3 for x, we get out -6. We can go ahead and draw in our axis of symmetry right here. Now let's plug in some easy numbers, and I have some easy numbers chosen for you because I like them. If we plug in -2, and you're thinking, oh my gosh, we're going to break this already, we actually get out -6.25, so that doesn't really help us much. We'll be like right there and right there. Because remember, we can mirror them. Now let's, okay, let's do another one because that didn't help much. If we plug in -1, we're going to be at -7. And you'll notice that this one's a little bit like wider than the last one was. That has to do with our value of a. Here it was -2, so it was kind of skinny. Here we have a -1/4, so it's getting wider. And this is at -7. I'll let you, if you want to pause this and figure out what the second difference is and the first difference is, and remember to look at our first difference, that'll help you figure out our pattern. But other than that, now it's time for a quick check. So I want you to graph each of these equations. As a hint here, this is the same thing as saying -2x, x minus 0 squared. You can FOIL that and make sure it's right, minus 0. So while it doesn't look like it's in vertex form, it really is. So go ahead, pause the video, graph these equations, check it on Desmos after you're done, and then that's it for this lesson.